shortnose sturgeon in Hudson.
So as Dwayne mentioned, Amanda Higgs, we'll be talking about our updated estimate for short-nosed sturgeon that we're just kind of completing and wrapping up. So first I want to start with the land acknowledgement. So the Hudson River is known as the Mikanatuck. It's the waters that are never still in the Munsee language. So the Hudson Valley is the ancestral land of the Munsee Lenape people. And despite tremendous hardship being forced from here, their communities reside in Wisconsin, Oklahoma, and Canada. So I'm going to start with a little bit of history of short-nosed sturgeon's abundance estimates and their population in general, and then move on to the project and some kind of cool things that we have developed along the way. So, as in many sturgeon species, it was not looking good. Early 1900s, population crashed, and the short-nosed was actually the first listed fish species in, under the ESA in 1967, and it was relisted when the Endangered Species Act was 1970 something. So there's been a couple population estimates. The most recent, besides the one we're doing currently, was in 1990. So between the one that was done in the 70s and the one that's done in the 90s, there was a 400% increase in the population. The estimate in the 90s was around 60,000 fish, done by Mark Bain. So has anything changed between now and then? The population was increasing quickly, so I thought it would be good to look again and see what was going on. So we use side scan and acoustic telemetry to update the estimate for short-nosed in Hudson River. So it's a Bayesian hierarchical model, and there's two major components, which is side scan. So we count the number of fish in multiple days. So we went out in the winter, 2 winters, 2021, 2022, and 2022, 2023. 2022, there was a period of iciness in Hudson, so we missed, I don't remember how many days, we went out maybe 7 days, but the following winter there was no ice, and it was like 40 degrees when we were out there, it was delightful. We sampled like 14 days that year, so between the 2 years we had quite a bit of data. It would take about a couple hours for us to go scan, and those brown and tan lines are the transects of the boat in the overwintering area near Surface Meadows. So here's an image of side scan sonar in case anyone hasn't ever seen it. If you saw Adam Bonmary's talk, I'm going to actually reference him a couple times during this. So you tow fish behind the boat, and it shoots out to the side, so you get images of fish, logs, mooring buoys. So it's like casting a flashlight on the bottom, so you get your target and then an acoustic shadow associated with it. So we can actually image fish and count them. A bunch of people sitting at a computer counting fish. We would go collect the data and then have someone sit at a computer and count. But to figure out what proportion of the fish in the population we're at the overwintering site, we acoustically tagged fish. So we tagged 100 fish over 2 springs near the spawning grounds in Albany to try to kind of get at that question. So this is kind of a dumbed down version and about as much as I actually understand of this process. So if you have any other questions, you might ask Shannon, or I can give you Dave Kasak's number because he's the one that actually worked on this. But so you have your estimate of your density in the area, the overwintering area, and then your proportion of tagged fish in the area. So you can get your total population estimate. So I've kind of thrown some numbers in here. You have count 200 fish, half of them are tagged. It's 400 individuals. So here's another image of from side scan. The black strip down the middle is the nadir zone, which is the area directly under the towfish that doesn't collect data. So this is out to the side, and it's 30 meters on either side. And you can see that this is only like less than 1% of the images we collect in a day. And there's 450 short-nose in this in this image alone. So it would take us, I don't know, like 3 hours to collect data. It would take someone sitting at a desk a day or more to count fish. So in this winter of 2022, 2023, we hired Adam. And if you hopefully got to see his poster last night, because it talks in more depth about this, but he started to kind of mess around with machine learning. He's like, why are you guys counting these with like people? Like, have you ever thought of AI? And he's like, yeah, I think we've talked about it 800 times, but no one has had any time to really go with me. He's like, can I do it? And I was like, yeah, let's do it. So he started messing around with it and started developing some algorithms, and then we started talking to a computer science person. So not only is the counting part, but the post-processing part of the data was extremely slow. So it had to go through a program and then break them into these images, and then someone would, at that point, would count. So it took a long time. It took someone a day to count the fish, but it probably took multiple days before that to get the images ready for the counting. So coordinating with computer science and Adam, he now can take the process like down to minutes. So it's a random forest learning algorithm to learn what short-nosed targets look like, so size, color, shape. And the automated approach, which was what his poster is similar, performs similar to the human counters. So this is kind of some results from our project. You have density on the y-axis and abundance on the x. So each little hump in color is a day of sampling. So the bluish colored ones are our first year of sampling, the reddish and pinkish colored ones are our second year of sampling. And the estimate was about 72,500 fish. I don't know if you noticed, there's this one big date where the fish just seem to be in the area, much thicker, aggregated. So removing that gives us, and it was an early date too, it was in December. So we removed that and came out to be with an estimate of about 80,400 fish. And comparing that to 1997, there's a 59% chance that the population is larger now than it was before. So they're listed under the Endangered Species Act. This is more delisting, because the population now is probably the largest existing population for sturgeon in the world, maybe. There are still threats, and obviously they continue, as different things happen in the river, construction, power lines, in water construction, disturbance of habitat. They will continue. So the population's not like, oh, it's just great, we can just kind of let it go. We kind of have to keep watching, monitoring. And these telemetry tags, we're actually learning about movement in the river, areas that they use. Things are happening, like I think Jim said yesterday in the plenary talks, like, you think you know, but you don't know anything. And I feel like every time we look a little bit more, like, we don't know what's happening. It's like, oh yeah, this is what's happening now. This is not what's happening. They're doing all these crazy things. So, they're 10-year tags, so we'll continue to collect information on there. And the cool thing about short-nose is they stay in the Hudson their entire. They may stray between river systems along the coast, but for the most part they stay. So we're getting very large amounts of data and movement for these fish. How they're listed in the endangered species under the Endangered Species Act is they're listed as one population. So short-nose are in rivers from Canada down to into Georgia, but they're listed as one population. So if we were to delist the Hudson, because it's doing really well, it would affect all of those southern populations, which are not doing as well. So what they would have to do is delist and then relist them separately, which I don't ever really see happening. And the other, so we talk about threats. So here again is a map of our transects. So between the 2 years, we changed what our transects look like. So the first map I showed you kind of had like some curved transects. This was the first, the other year that we did, and the transects are a little bit more straight. But each line is made up of dots, which is probably hard to see. So each dot is the abundance of fish in that sampling area. You can see in the red circle that the fish are very, very tightly congregated in those areas. And if anything were to ever happen, it would wipe out a pretty large portion of the shortnose population in the Hudson River. So the darker dots within the circle are highly congregated fish. So when people were counting, there was like lots of zeros, and then 1,000 fish in a box. And that's all I have. If anyone has any questions. Anybody with Karen can ask a question? Go ahead.
Wow. So what makes that spot so special?
Great question. So it's on a corner. So it might be hydrodynamic in the Delaware, according to Dwayne. Their shortnose overwinter on a bend just like that. So it could be something that. So when we were there sampling, we watched fish come to the surface and go back down, like they were moving throughout the water column. So I don't know. They just don't stay on the bottom, and they're moving quite a bit. So yeah, I don't really know. It'd be great to figure that out.
How do you know all the dots are still short of sturgeon?
So we did some ground truthing with gill nets throughout the survey, so we know that they were short nosed. And when Ross Burdan sets the nets, that was like that outlier day where we caught like 300 fish in our nets that day. Any questions? Yes.
Amanda, great talk. You removed some of the inferred fish that showed up early in the season. What do you think they were? Do you think they were fish just misclassified? Or what was it?
So we set our overwintering time, so it was even between the 2 years. They were different, like temperature-wise and stuff. So we set kind of a set time where we thought fish were moving in and staying for the winter, and not moving in and out. So removing that outlier day, we set our overwintering area to be just after that. Is that right, Shannon?
Yeah, there was a lot of fish that were still moving in and out of the overwintering area at the beginning of the year. So the system wasn't closed yet. That's what I'm getting. Yeah.
That's what I was trying to say. Thanks.
Jim.
Wonderful talk. They seem congregated in a small spot, which seems to make the population very vulnerable there.